Well, I'm Michael Crusoe. I'm the Common Workflow Language community engineer and one of the co-founders. And today we're going to do a pretty deep dive through CWL, through the bits that are pretty well known, and for things that we have not documented well, which may be of interest to some folks who've used CWL already. And I've been told that you are all asked to kind of get your feet wet a bit, to actually read and go through the general introduction to CWL user guide. It's okay if not all of you have it, but I'd just like to know who actually read it, who read the user guide. Hands high. Okay, oh, you all did your homework? Okay, but who actually went and maybe did it and got it to work and wrote some CWL? Okay, so a third to a half. Okay. So this is, well, I'm going to start with my standard slide deck. But at any time, we can go in and talk more details about things. I'm going to be a bit more technical today, but I am happy to talk about policy and funding and sustainability and big picture stuff too. So we've got 3 hours. It's kind of cool. So please feel free to ask questions, be comfortable, and hopefully we'll have a productive and interesting time together. So we are being filmed, so I'll be repeating any questions that are asked for the camera. So a little bit about me, for those who haven't seen me talk or weren't at the talk yesterday, just about my background. I'm from Phoenix, Arizona. I spent time in industry as a programmer, developer, sysadmin, and then I studied microbiology as the obvious next thing. Immediately got into bioinformatics, did lizard genome assembly and analysis, and then worked for Titus Brown's K-Tumor project up in Michigan for a couple years, and then followed him to California. And then now I'm based many moves later in a very complicated story. I'm actually based in Vilnius, Lithuania, for personal reasons. So just to give a feeling about my background, and I'm happy to talk biology and comp sci and all sorts of other things. So I think this crowd, I'm just going to skip a lot of these sort of motivation slides, but I'm happy to kind of come back to them if people have questions. Just as a reminder and a theme, the common workflow language, I would say all good workflow systems are about separation of concerns. That's the goal. We want to describe our research, our data analysis, our steps, how they're connected to each other, right? So we can think about the research and the science, and then we can have a separate conversation, with a separate part of our brain, or maybe with different people, about getting that to run optimally with the resources available. So the CWL gives us the language so that we can have these sort of different conversations which tend to involve different people, though some of us work in between them. These are some fun slides I always include about sort of why have a standard, the state of things. So we collect workflow systems used by researchers and scientists, and I think Bernie's got his own list that we're going to combine in. And I know this is a bit blurry, but the point here is that it's very long. It's actually, the screenshot's out of date. I'm up to 121. If you know of any extras that aren't there, please let us know. So the goal of CWL, though, is to make it easier to move amongst these systems. I think you all have done your reading. You showed up. You're kind of aware of the context here. So I will skip, I presume everybody's sold on having a standard, or are anybody standard skeptics? That's okay. Yeah? Okay. We can. So, but I just want to hit some key points for those who may be new to thinking about CWL. There's always some confusion around, is it a platform? Is it the 122nd system to install? And CWL is a standard. It's a format to enable interoperability and portability between research workflow systems. So you don't purchase, install, run CWL itself. You run some other workflow system that supports this. So we provide a schema, a specification, and test suites for these implementations. And we really do think about these different computing environments. So as we might have collaborators who use cluster computing, grid, or used to being a single machine, when you describe your workflows using the common workflow language, again, we did that separation of concern so the executors can deal with those differences in the environments. So along the way, we picked up some friends and folks. We started a couple years ago at the Bioinformatics Open Source Conference. So my co-founders are Peter Amstutz from Curaverse, John Chilton from the Galaxy Project, and Boyce Chijanik from Seven Bridges. But then we've picked up a lot of friends, and we've enjoyed also learning from their experiences. So we take a lot of inspiration from the Workflow Forever and other efforts from the Taverna crowd as well. Yep. Oh, so we had a hand too. I didn't even see it.
From your previous slide, is interoperable and portable the same thing for CWL?
And I'm standing too far. Sorry about that. So the question was, what is interoperability and portability? I would say portability, it's an interesting question about the distinctions. There are systems that are you can sort of technically fit one thing in the other, but then you actually have to do quite a lot of work. And so I don't know how portable that is. So I guess I use both words to emphasize the goal is seamlessness, to minimize the amount of work done to bring somebody else's workflow to your system. Do you make a distinction yourself in your research between the two?
I'm trying to make a distinction.
Okay.
Yeah. So that's why I thought that I should ask, what's the goal of CWL? Is it portability or interoperability?
It's both.
And
yeah.
I know there is kind of very small differences, but CS people kind of distinct between these two terms. I'm not sure how and why.
Yeah.
But I'm trying to research on it, so I thought that I should clarify what CWL is trying to achieve with portability or interoperability.
So right, because it's a standard, it can be used in a couple different ways. So some people will use CWL to import or export a description or as their underlying way of representing a workflow. So that's why that kind of varies. Does anybody in the audience have off the top of their head, a good distinction between portability and interoperability? No? Okay, we can think on that later, but you had a question?
I was just going to ask, so from a practical perspective, how should, and I mean, I haven't done background reading, sorry, so how would people actually use this standard? Is it at the level of the existing, one of these 120 existing workflows that developers there should come along and find a way to translate what they're doing, or is it at the level of the cluster administration where there should be some sort of layer that allows things to talk to each other in this language?
Okay, great question about sort of current state of play or how people might be using CWL. So where were my? So Curaverse's Arvados platform supports CWL. You can use their hosted version or run it on your cluster. Seven Bridges commercial platform supports an older draft. Their rewrite in Java, which is called Ravix, is open source. Though I don't know if their job scheduler is open source yet, but that's on GitHub. Galaxy support is growing. UCSC has the Toil, which is very popular on traditional academic HPC clusters. So we're talking about things that you install on top of that. However, there was an interesting article 3 days ago on IBM's blog that they've taught the LSF, so not basic LSF, but they also have a workflow system, and they've taught that to consume CWL. So I don't know if that's a commercial or free product. It probably is commercial. So we're seeing integration at a couple different layers, but typically you're going to find a project that talks to your backend scheduler, because backend schedulers tend to be pretty low granularity. And that gives you other opportunities, right? Because maybe you want to do meta scheduling. Maybe you have access to many different resources, and some of these systems can do meta scheduling and work with many different availabilities. So that was a useful question. Anything else, or shall I continue on? Yeah? Okay. So I was kind of talking about, one thing I like about CWL is I get to do all my development on my laptop and my text editor at the command line, because that's how I enjoy working. But there are graphical user interfaces being developed, and of course, once Galaxy gets full support, there's that great workflow editor in Galaxy. So I enjoy the fact that it helps people collaborate who might normally have different working habits. And yeah, this is a very incomplete list, and I can pull up let me pull up the website right now, just so we can all see. Let's see here. So just who haven't seen it, there's a list of, On the website, yes, there we go. Sorry, I turned off my Wi-Fi. There we are. We do have a list of backend supporting and their platform support. And we're missing one because I haven't merged it, which is Airflow. Somebody's adding CWL support to Airflow. There's some plugin modules for that. They have about half the conformance tests running. So yeah, right now it's mostly you'll find something to run on top of your existing scheduler, just to answer your question. You see some people were clever, and then they noticed I put the address of the slides up top. So yeah, please feel free to share those and look ahead. So our design principles are, so we do really care about so CWL is a declarative approach. And we made that choice versus having a domain-specific language because we care about generating graphical user interfaces, converting between languages, and also programmatically generating code. We allow extensions, and we do it in a way that's reminiscent of modern web standards, and we support linked data. I'll go into some more of these details. So I think is this a mixed bioinformatics crowd? There's some people from not bio, not life sciences here. You don't have to raise your hand, well, no shame. But I'm gonna use a lot of bioinformatics examples. The Common Workflow Language project did come from bioinformatics, but we worked very hard to not build anything in that was particular to that. So we allow plugging in of these vocabularies from each discipline or subdiscipline. An example of that is the EDEM ontology that describes bioinformatic file formats and operations and allows us to reason about them. So we can be smart about those, they can develop their standard, their ontology at their own speed, and we just get to make use of it. We're gonna get to some syntax, but I just wanna highlight some approaches to think about how people are already using it. Just like you already see Galaxy workflows being published, we certainly are thinking about publication, reproducibility. I'm personally actually a little bit more motivated about reusability. And then we're seeing workflow creation across continents. So there's a great local example that Farah and Sarish, I'm so sorry. I'll blame the jet lag, but that's no excuse. Created GATK wrappers in an early version of CWL, and that got picked up by the H3A BioNet Pan-African Bioinformatics Network. They ported it to 1.0, and then those are being continuing used by them and folks in Europe and North America. We would have never seen this in the past because nobody had the same infrastructure for doing that. There already are contests and challenges that leverage CWL, and I'm actually interested in seeing more of this, where we bring the computation to the data because maybe the data is big, or because maybe there's a lot of legal restraints about accessing the data, but we can get easier review of running a bit of computation. Maybe it's, is there data here I care about? Then, okay, yes, we'll go negotiate and sign contracts. Or maybe give me my full result, you'll review it to make sure it's not leaking private information, and I can get it without having to that upfront legal agreement, so especially for human data. So there's lots of slides about and write-ups from early adopters, so I recommend finding this slide again. This is from last year's Bioinformatics Open Source Conference. But let's start looking at some real CWL. So this it's a bit blurry, I'm sorry. The point of this slide was to give a sense of the level of complexity folks are representing with CWL. And this is visualized using a website developed at the University of Manchester by an undergraduate. And so we can certainly do this. A goal of CWL, though, is also understandability. I mentioned reproducibility. I think reuse is really important. And to support that, we allow a workflow to be a step in another workflow, and lots of human-friendly labels. So this is a workflow I'm converting from a pile of Python scripts and a bit of Perl at the EMBL EBI into CWL, and the way I've structured it is to really try to make it easy to quickly, if you're at all in this area, to understand what's going on, and then you can drill in deeper. So right now, these are static visualizers, but I'm sure, hopefully people will develop, and it's likely to happen, more dynamic ones where you can zoom in real time. So just give some credit to everybody who's been helping out. This is a big team effort. And this is only the credit for folks in the spec. There's also reference implementation and associated tooling. I'm not really going to talk about process right now. I'd like to get in some details, but I'm happy to come back and chit chat about this. So we've got some choices. I can go through the syntax. It's kind of my standard slides. But supposedly you all did your homework. So it's OK. I can go through this again. Maybe it's a good review. Or we can dive in deeper. What are people's feelings? Does anybody? It's OK. Huh?
Start from the start. Like,
you.
Look at it, but it'd be good if you
OK.
explained it.
All right. Great. We'll do some reinforcement. Awesome. So I'm going to walk through, just to step back, right? Common workflow language. Why am I talking about a command line tool here, right? Because that's the base unit. We have to describe how to talk to this program, how to generate that command line, how to get the data in there, let the program run, then how to get the data out. So this is the mucky bit. These are the annoying details. Once you have this, then we wire up the workflows. We connect their inputs and outputs of these tools. That's kind of the easier part. And this is actually where you see the most divergence in how these different workflow systems try to do this. So as you can see, it's a very declarative format. It's YAML-based. I've kind of color-coded this, and we're going to dive into the details. And at the bottom here is an example of plugging in using linked data so we get to know about all these great file formats and the relationships that the EDEM ontology people have done. So as a shortcut, we set the namespace EDEM, which we get to use elsewhere. So that actually, when I say this, I actually mean this whole string prepended by the actual identifier. And then to enable the reasoning, we even link to their OWL, and which sort of implicitly shows which version we're talking about. So for bioinformatics, this is great. You can imagine other communities who are just very different. They want to develop their own. You can plug this in. And so this is one of the ways we try not to be specific to a particular field. So let's look in. Let's start at the top. The basic file format is not XML. Yay. I don't know. OK. All right. Some laughter. I should make more jokes. So I get excited about this. This was on purpose. We chose YAML to be a bit more human readable. You know, in the next 12 months, probably a lot of CWL will be handwritten. There's already a lot of CWL out there. As the tooling gets better, though, we don't really expect people to be looking at this syntax, right? We expect them to be using, just like Galaxy users don't look at the Galaxy tool definitions or the Galaxy workflow XML. But today, a lot of people are going to be doing this. So we're going to describe a command line tool today. We give the version number of the spec we're using. And of course, optional, but highly recommended, we can include documentation. That can show up in user interfaces or help ourselves. The next bit we have in this file, and I should step back a second. As was well pointed out in a local blog post, the ordering of these sections, by the way, does not matter. I just sort of put this because that's kind of how I think about this. But just so you know, it's really, if we think from a YAML syntax, this is actually just a bunch of key value pairs. So this is the key is hence, and here's some stuff. Here's inputs, whatever. So if we think about the low-level syntax, you might then notice that these actually could go in any order. These are special directives. These are not part of the YAML standard. That's something we did specific to CWL. All right, so we'll go back and look. If you can run Docker containers, it's very convenient. And lots of the vendors and people are moving to systems that do that. So we support that. But CWL itself conceptually does not require the use of Docker or other container technologies. So here we just have the Docker poll statement. I abbreviated it to fit in the slide. And this is also an example of how the extension mechanism works. So you could come up with, somebody name a scheduler they use. Anybody? Slurm. So maybe Slurm has a magic flag that makes things faster if you run things in a certain way. I don't know, right? So these sort of local extensions, local hints. At any time, you don't need to ask permission. You can go make up your own extension to the spec. And we just sort of ask that you kind of flag it as a hint or requirement. Is it going to change how things run? It will change the science of the research? Well, that's a requirement, right? It's going to change. You need to understand that extension. If it truly is optional, it's just kind of bonus or an optimization, yeah, it goes under hints. So this is like, yeah, this is a convenient way to get the SAM tool sort command installed. So let's go with the next bit. Any questions about the extension? feature. We can come back to this. It's cool. Yeah. Okay. So the goal here, right, we're going to explain to our workflow system what our inputs are that are available. And then we also need to take those inputs and represent them as if we were typing on the command line. So the SAMTools sort command, which many of you may be familiar with, takes in, the way we're going to use it today, takes in a single file of sequence alignments and sorts them. As an optional field, we include the format. We use the EDIM identifier. So EDIM's identifiers are a little unfriendly, but so we can include the comment, luckily because it is YAML. And so we say, so this aligned sequences, that's a name we got to make up to be friendly to people. This could have just said input 1. I would say that's an anti-pattern. We really want to describe conceptually what's going on here. So because we're going to have this list of inputs, but we also need to indicate how is this going to show up on the command line. Well, this is pretty easy, this command. We just do SAMTools sort and then the path to the file. So we call that connection between the input and the command line binding, input binding, and we're just going to put it at the first position. So as long as there's some default input binding rules. So sometimes we just need to have some sort of syntax here to pull it in. We can do prefixes and change the value. Every well-behaved tool and most of the not well-behaved ones you can represent in CWL, if not all of them. We try to learn from the experiences of the other workflow systems and their sort of proprietary syntaxes, what they had to do. So just to step back, we're going to take this top bit with our base command, SAMTools sort, and actually make a command line out of this. So when you run the reference implementation, which is one way of running CWL, you do need to provide an input object that describes what you're going to stick in. And actually, the input object is, you can think of the input section, so this is from the CWL command line tool description. You can think of this actually as a schema. This is what is acceptable input. So our input object needs to match this. So we have, it has to be type file. Well, this is an instantiation, so our classes file. If you're using other types, you don't need to define the class because it's implicit in the YAML syntax if it's a string or a number. Here we use the long version of the format. I could have still put the other shortcuts in the bottom here and used the shortcut, the namespace prefix. So this is where we're going, right? This is, if we've worked low level in Unix, we know that command lines are an array of strings. So right, I type SAMTools sort, and then in this instance, example.bam. So just give you kind of a schematic overview of conceptually what happens is you take the base command, you evaluate all the input bindings, so the positions or prefixes or other transformations. There's another set of if you have fixed arguments, it's not shown here, but I'll show an example, and it's in the user guide. You can actually have fixed arguments as well that aren't modified by the user. And we put them all together, and there's rules in a fair amount of detail in the spec about how this goes to, but it's pretty straightforward. Any questions on the simple example of input binding? Yeah.
So is there a way to cope with tools that can handle multiple formats? So if the schema is a back file or a SAM file?
Yep. Yeah, the format field is either a single entry or an array. It can get tricky though if the tool expects things to behave differently based on the type of, if it's not going to do auto detection. So we can support that. A feature we don't highlight in the user guide much is actually we allow the use of JavaScript to compute certain values sometimes. It's not a part of the core spec. Not all platforms have to support it. All platforms so far, however, have chosen to support it. So you can imagine a tool that you need to pass in one flag if it's this format and another flag if it's that format. You can deal with that. But whenever that happens, I always try to take a step back. First off, do I need it for what I'm doing right now? So your command line tool descriptions can be simple and just do the bare minimum. They don't need to describe every possible use of the tool. And sometimes that's actually a bad idea because it gets too complicated. So I really, especially, let's say Trim-O-Matic is a famously complicated tool, or some other ones that have lots of subcommands. It's nice to take one slice through the functionality because maybe you're not ever going to use those other bits. So it's a bit of a dance as well. I think we try to deal a lot with the flexibility that's required, but I would also say at some point you need to fix your tool. And maybe it's not your tool, so you need to fix upstream's tool and help them out, right? Like, yeah, so it's a bit of a dance back and forth. So we can probably handle most anything. Worst case, you always write a wrapper script. But at some point, maybe we should also fix our tools.
Does the CWL spec sort of talk about how does it actually know what the format of something is? Is it purely based on file extensions? Or does it actually try and...
Yeah.
What are you expecting the implementers to do to enforce type safety between the modules?
CWL spec provides lots of useful things, but we don't tell anybody they have to do most anything. We're not very opinionated in that way. So we provide the file format as a field that can be useful. In the reference implementation, if there's a format listed, your input must have it, because it tries to be a bit more correct. But we don't actually say that the platforms have to enforce that at all. We step back, yeah, extensions can be useful, but you'll get naming conflicts, especially across fields. But yeah, we should register our file formats, not just in EDAM, but in the IANA media type registry. And when we register them, we can give them, if they're magic bits, you can use to auto-detect. They should go in that registry. And it's actually a very simple pull request to the people who write the Unix file command to teach them about the magic bits as well. So we should participate in that larger ecosystem of how file formats are regulated, but we don't do that in bioinformatics right now. So acknowledging that, we say, well, we'll make it possible, but we'll let the platforms kind of pick their own thing. Because you don't necessarily want to get in the way of people if there are errors. I like that Galaxy, for example, is pretty opinionated about file types. You got to tag the right file format. It will try to auto-detect. And when you go to run a tool, it's not going to list files that aren't marked as compatible. But from a specification perspective, we make the data model available, but we don't tell implementations what to do.
I mean, it's getting quite complicated. I mean, FastQ is easy, so just it's a file format for one thing. But BAM, it can be sorted or unsorted,
Yep.
metadata or other stuff.
Yep.
And things like HDF5, container formats, they can contain anything.
Of course.
The format is irrelevant, which hasn't got the right block inside it with the right attributes.
Right. So the question about HDF5 is a great example, but that's why we should formalize these extensions, these file formats. So like the geosciences use NetCDF, which is built on HDF5 and saying you must structure these things using that format this way and have this metadata. So we can still do this, right? So if there's so the EDAM one, not only does it give identifiers for these, but it lists their relationships. Because some tools can actually work on, you're using a generic tool to muck with HDF5. But for example, the EDAM for geosciences, whatever that is, should say, yeah, NetCDF is a narrowing of HDF5. But these relationships they do capture, like FastQ, FastQ, but this quality score encoding. So a lot of the stuff that, for example, Galaxy has in code about those relationships, EDAM has there. So we should continue to we can't solve all the problems, but we'll participate in the ecosystem. So we should continue to register these subfile formats someplace and capture those relationships. But sometimes you can't fix everything, right? Like you're just making it easy to do the right thing.
As we are going into the detail of the requirements, is there any way in the spec that we can declare the compute and storage requirements of the tool?
Yep, so resource requirements. We do have that. It's in the spec. It's not in my slides. So I can jump to that right now, or we could continue with this and come back. What do people want to learn about resource requirements, or should I wrap up this example? Let me wrap this up.
Yeah, sure.
We'll go through workflows, but now I've written it down, so we'll make sure we have plenty of time to get into those sorts of details. Okay, so I think we made a command line. Yay! Woohoo! Sample sort. But now what, right? We got to plug this into the rest of our system. So that's where we take our output parameters. Here, it's very similar to what we did for inputs. We give it a nice name to kind of indicate some stuff. We get to use this nice shortcut because it came from the standard output stream. And we'll, again, tag it. It is a BAM file, but yeah, you're right. It's a different sort of BAM file. So we can do things at the human layer, giving things nice names to help people connect them correctly. But at some point, we can't necessarily represent all the detail all the time. But if somebody wants to do that in a certain area, they can. We're not going to get out of the way. Get in their way, rather. Yeehaw! Let's talk about workflows. I think that's why we're here. In the common workflow language world, we model workflows using data flow. This model means it's not step A, step B. Nope, it's a named output from this step is going to get connected to a named input of that step. So maybe it goes to this other step as well, or maybe it skips steps. So you can get this directed acyclic graph. Any workflow can be a step in another workflow. We do some parallelism if you've got multiple files or multiple parameters, multiple instances of a file input or other parameter input. You can scatter over them. You can run things in parallel. So I'll show an example, but we can go in more detail. Many people ask for conditionals and looping. This is quite complicated from the workflow system side. So a lot of things that sound like they're conditionals and looping that you can actually implement using scatter-gather or other techniques. And so we've discussed this as a community, and we've kind of said, okay, here's the development process for this, which is somebody should go try it out in one system and report back. So we're waiting for that to happen. It's not something I'm personally at the moment working on.
So when you say conditionals, do you mean conditionals driven by file metadata?
Some people want workflows where you dump in almost any sort of data, it looks at it, and then makes a decision to run drastically different downstream workflows. At that point, you're not a DAG because you're doing this branching, this hard branching. I guess it's still a DAG, but we sort of presume that there's a beginning and end. Now you can kind of branch and come back. You can do a bit of those sort of tricks, but if your endpoints are totally different, that's what we think about conditionals. So we think that, of course, is useful. People should do that. They should put that logic in a standalone thing outside of CW. This is what you can do today, right? You can put that logic outside, make the decision, and then launch the workflow or sub-workflow that matches that. But from some of these schedulers want to do a lot of upfront scheduling, and that's going to kind of break things for them. So similar thing with looping. Sometimes we talk about looping, we say, well, I want to run this 5 times. You're like, well, why? Oh, it's because I have 5 input files. Great, so we can scatter over those 5. Some systems, though, they really want to run it 5 times and it's feeding back into itself, or they want to run it n times because it's a number. So those sort of modeling software situations, we understand that happens. It's not something we currently represent in CWL. But you could go develop this on your own and figure that out and make that a community contribution. So that's the model now for how we're evolving, is that you go try out a new idea on a particular implementation, convince others it's a good idea, then it's going to come back in a spec. So it's like how the web standards grow, if you're familiar with that. So we're going to do an example workflow. I put it in 2 columns just for readability. And I'll step through this. But this time we're a class workflow. And since we're going to use the scatter feature, and in 1.0 we made a lot of stuff optional just because we want to be really friendly to implementers. This will probably become required in a future version, so you wouldn't ever have to declare you're using the scatter feature, but right now we do because we're going to scatter over here. And so we're going to use 2 tools, and it's the Unix grep command and the word count command. They're defined in external files. So just like we had before, the command line definitions, command line tools, that's what this is. So I'm not going to show it right now, but you can go here. But they're pretty straightforward. So this is showing the modularity, right? We want to reuse those tool definitions in many workflows. Like the command line tools, we have inputs and outputs for our workflows. But here they're a bit simpler because we're going to have wire stuff in here. So this is just a toy workflow. We're going to take in a list of files, a pattern to search over that. So we're going to run grep over those files, find out which files to get the matches per file, and then count those number of matches using the word count command. And then we'll have one output that summarizes all that. So let's draw some arrows, and I will step us through how this all connected. So these steps, the order that these steps are written in the file has nothing to do with the order they're run, but conveniently they are written in the order we will run them today in our heads. Again, the ordering is implicit in these connections between the inputs and outputs. So we look at what we happen to know is going to be our first step. The actual definition is going to be in this external file. So we need to say, well, this external file itself is going to have inputs and outputs. So how are we going to wire those up? So it needs a pattern and a single input file. But hey, if we look back here, we provided a list of files. So how are we going to cope with that? And again, we're going to use that scatter feature that says, of the input parameters, in file, go ahead, even though that's an array and it wants a single file, go ahead and run those, perhaps in parallel or sequentially, but sort of unwrap that array, issue separate jobs, take all the output, and automatically wrap it back into an array. So that's the gather is always implicit. Because sometimes our tools might produce 50 files, and it's running on a remote system, and maybe we only care about 3 of them. And so right now, we actually we list each output we actually want to copy back or consume, because maybe we don't want to copy all the files back. So that's what the out section is. It's always a list. Maybe there's only one thing in it, but it's a list of which of the outputs we want to bring back into the workflow. So here, again, this was a matching. So the pattern for the underlying tool came from the pattern input of the top level workflow. Same thing here. So next step, we're going to do the counts. So even though this only gave a single file, because the scatter gather, all those individual runs of grep got wrapped up. So all the files listing the hits from the grep tool become an array. And so here, when we specify our inputs, we say, yep, this has a thing called int files. It's not very creatively named. It's coming from the grep step, the output named out file. And so the word count command takes in that array, no problem. It will produce a single file of the list of counts, and then it ends up becoming our overall workflow output.
The scatter is the output order preserved as the input order?
Yes. It is up to the platform to preserve the ordering. Yep. So, right, we had 5 files, 1, 2, 3, 4, 5. The grep results need to be in that order, 1, 2, 3, 4, 5, whatever order was presented. So it's not it's an ordered list, both sides. All right, questions on this super simple workflow? Yeah?
Not that simple.
Yeah, well, okay.
I was just wondering, you said like the steps here
Yeah.
are not necessarily going to run in that order. So where do you specify here which order they're going to run?
Yeah, so order is specified by these connections. So you infer the order. Yeah, so I know, this step, it depends on the grep step. So I wouldn't run that first. And I look at the other steps. Oh, this only needs inputs from the top level, the workflow level, so I could run this. And then, okay, I've now looked at all the steps, so which steps are available to run? This step is available to run, so I can run this step. Then we repeat the process to see what inputs are available. At this point, that step is run, that output is available to be in the input for this step. Great, then I can now run that step. Whatever scheduling algorithm people want to use, but like that's one example of a you basically look to see whose inputs are available, whose are waiting on something, run the ones where the inputs are available.
Surely in some complex case, or not even that complex cases, you will have the same output files that will be involved in different steps anyway in your program.
Yep.
So then, is that CWL thinking, oh, okay, which one can I do first? And surely there will be some clashes.
Yeah, so right, we provide a standard. It's up to the implementation to make those choices, but I don't necessarily. So right, so either all the inputs are there or they aren't. If they're not, if you're still waiting for another input, you can't obviously run yet. But if many steps are available to run, well, if you're on a single sequential system, you'll use some tiebreaker rule. But if you're on a parallel system, maybe you're just kicking off jobs and then a scheduler is assigning those based on resources. Yeah?
So do you have constraints on the names of attributes and variables? Like, for example, in the input section, so should it be like implies if we put something else this way?
It does, yeah. So the keywords here, so here are the keywords here that you can't change, right? Class, workflow, CWL version, requirement, that stuff. This you can't change, but the name of the input you can change, right? That's changeable. These are core CWL types. You can also make up your own types. So again, the type, that's a CWL type. But the name of the step, that's freeform. It doesn't have to match the name of the file at all. In fact, oftentimes I could say, because maybe I'm writing this for different audiences, so I don't really want to, maybe people don't want grep as, that's fine. I'll say find string and file. That will be my step name, right, to make it more readable. And count lines, right, instead of WC, but the run command would be the same. So in and out, those are keywords, but again, the names of the steps and the names of the parameters are all human chosen. You should try to make those as to communicate as much meaning as possible, because they will tend to show up in visualizations and log files.
Why doesn't it inherit the pattern type def from the inputs? What do you need to repeat that?
So you're talking about this one here?
The pattern string.
Yep.
Why doesn't that box inherit that from the inputs? Because you've already got in files there, so it doesn't know the type of in files.
Yeah, there's no typing information on this side. It's true, though, that in the grep command, we had the typing information on pattern in file as well. That is a bit of repetition. So it's been proposed that in the future, we could probably leave some of that out. But it sort of depends on kind of which angle you're looking at these files. Are you looking at the workflow first? And then you might want to still kind of know the steps. Or are you looking from the underlying tools upward? So we're going to kind of play around with that. Does that answer the question, or were you asking something else?
No, I think that's
Yeah.
right. It does seem to be
So there's definitely some repetition. Like almost always, we want all the outputs. So maybe we should make that optional. Okay, yeah, we know that. Here, the repetition here is not about typing. This is more about wiring. So yes, the name happens to match, but we don't do name matching.
The second pattern is coming from the inputs.
Yeah, so the input for the underlying tool comes from the input at the workflow level.
So if I put here like pattern 1, I should put that pattern 1 as well.
Exactly, yeah. Yeah, so that's not some sort of CWL keyword, that's a name a person came up with. So name a person came up with, the actual typing information.
I think it would be helpful if they show only one, like only grep or WC is the underlying tool file. So to link the input object directly with that, because
Yep.
we do in files at times because it's in the underlying grep.cwl too, right?
It is.
Right now, yeah, right now.
Should I go through and click in to see the underline? Let's hope the link still works. Yay.
So that pattern is in file.
I can't actually see the screen. So, that was the underlying grep definition. We have a similar one for word count. Yep, so you're right. There is repetition of the typing information. But yeah, so it was to match this term.
The input object has to match this underlying file description.
Yep, and you can think of it in workflows, we sort of generate input objects for the step before we run it, so from a conceptual layer. That's kind of what's going on. Okay?
Obviously, grep can take standard input.
Yep.
I know there's standard in and standard out. How does CWL kind of handle that? Like, how could you link things, or is standard out a file type?
It's a shortcut. So if you do type standard out, which we did we do that here? Yeah. So type standard out is actually saying type file, because there's another construct you can say standard out colon and then a file to write the standard out to. I mean, it's a conceptual shortcut. The implementers can do whatever they want here. But yeah, this is saying, yeah, it really is a file, but the one that's coming from standard out. So it's like a shortcut type.
So the implementer, the runner, could use types instead of intermediate.
Exactly. And actually, file inputs and outputs have a field optional. It's called streamable. So if you know that you can have streaming output or input here, you can flag it as such. And smart implementations can do a direct connection and not make it delayed by spinning Rust disk, the enemy of fast computation. But yeah, so implicitly this is really type file, streamable true, and that there's standard out is maybe perhaps also defined. And likewise, you can stream to standard in. We made that a bit easier in some revisions that are coming out soon. Question from someone new? Yep.
It's not important, but I noticed at the top there you've got the shebang line with the CWL runner.
Yep.
So this is just for a single command line tool. What will happen if you just run this file as an executable, given that it's not a workflow, it's just a tool?
So CWL-runner. So what was pointing out that I've got the shebang here at the top, or that hash exclamation mark. And so CWL-runner is a generic interface that platforms can choose to implement. we ask them to, at least for the conformance tests, but some platforms you never interact on the command line. So if you, for example, fed this to the reference implementation, it would want to also know, you would do like, the path to this file. You should provide a path to the input object. As a nicety, the reference implementation actually allows you to construct a command line to run your command line tool, which is more useful when you're running workflows. So you can actually just do path to this file if it's marked executable, and you've got the reference implementation installed as CBL runner. And then -- help to actually get a listing of the options you did define and a bit of the help text. For the command line tools, that seems a bit redundant because ultimately you're running a real tool underneath, but it's a nice way to test your code, but for the workflows, it's very helpful.
So will it prompt you for the inputs or something like that, or will it just tell you what you need to give it?
You can either write command line options to provide the inputs, or you can give it a path to a YAML or JSON file that has those inputs, that input object. Yep. Cool. Okay. Yeah. You did have a question. Thank you.
File system, object stores and data stores, I guess, those sorts of things.
So I had a question about like file system and what about non-file system things. In our input objects, let's look at that real quick. Where did we go? Okay. Here I used a location. Typically this is a path, actually. I should probably update that. But we also allow for a location. And so that could be an S3 URL or some other system link. It needs to be something that the platform understands. So we're not telling platforms they have to support every object store, because obviously they could be on a different platform as a different interface. But really, I mean, this is where my data is in the context of the platform I'm running. So it makes sense to allow these platform-specific things there. Yep, so it's location. Typically, people use a path for a local path, but yeah, location is any IRI. It's like a URI that has Unicode in it. So whatever the platform supports.
Can you use an alternative location in path, or location is just for external resources and path can be on your system?
Well, your location could have been like file : / right? So I think that's kind of implicitly, because we're doing a relative path here. But path always means, because the model is command line tools running in a POSIX kind of Unix environment. We ultimately need to deliver a path to the tool. Yeah, some tools know about object stores natively, but that's not really a consistent thing. We're not really concerned with that.
But if you want to stream it in, for example,
yeah.
So the command line tool doesn't need to know about S3, but your implementation can then stream it.
Right, yeah, so if your input was marked streamable, good, and you're using an object store, then a smart platform can go and do the equivalent of wget or curl from the object store or the local command and pipe that directly into the tool. But if it's not marked streamable, you can't do that. You'll need to either use a user space file system or other mounting thing or copy it into that running. So that's another place where maybe you're not necessarily connecting all your tools up, but you're streaming to and from object stores. That streaming hint is really important from a usability perspective. And again, we give all these hints and information in the tool descriptions so that the platforms, as they support them, can make use of them. Trying to do that separation concern. Okay, how are we all doing? Do we need a tea break? Yeah, maybe? So the next bits are like doing a bit of a deep dive. Well, first we'll skim the user guide, and I'll just kind of talk through some stuff, because it sounds like some people didn't have hands-on experience. So at least I'll talk through it. And then I'll go through all the stuff we've been meaning to put in the user guide, but we haven't gotten around to yet. There's actually quite a lot the spec can do that's not in there. So that's sort of the agenda for the rest of the morning. So just because it's come up in many conversations I've had on this little CWL in Australia tour, I want to plug a related standard called Research Object. So CWL is going to help you with your reproducibility, your portability, describing what you did, which will help systems generate provenance. The whole point of this is to get something done. You produce some outputs. And how do you communicate that to other systems, your users, maybe your publications? And so I really recommend looking into Research Object. It's a data container. Takes your, what we would call in computer science an artifact, some output, not artifact as in a technical or biological sense, but and some output. So it could be a data table, binary file, figure. results, whatever those are, and helps you tell the story of how that output came to be. So it's that file format. It's a manifest. Could be in some sort of archive, like a zip archive or something else. And you can issue an identifier for this. But it says, yep, here's my output. Here's who did the work on all the different types of work. So you can models the attribution, models the provenance. So if a workflow like CWL made that thing, then you can include that. If it was not CWL, you can at least include an abstract representation of that workflow. So you can still represent that provenance. And also the metadata, and here's the source data that was used, and here's metadata about that. And it's all about plugging in existing vocabularies or making room to plug in new vocabularies to describe this. So each little field and use case and whatever, develops, the model that's emerging is that they are developing their own specific metadata, but this is about a generalized container. So if you're thinking about communicating the results of all the great workflows you're working on to the next system or the user or a publication, I would say think about research objects. Ties all those pieces together. So we often get questions about metadata and provenance and reporting and whatnot. And we could, on a technical basis, put that into the CWL specification. But we're not going to. We really kind of recommend people use this or something like it because this ties together all the existing standards. It's actually, as a standard, it's pretty lightweight. It's mostly pointing to existing efforts, but bring it together in one manifest file. So it describes the object, the output, it's a graph, a table, a binary file, a report, and then gives all the rest of this pointers to the metadata using existing vocabularies, W3C Prov, Dublin Core, all the good stuff. It ties it all together. So this is a preemptive thing I'm showing you because I would kind of refer to this as, well, what about that? Yeah, I think research object does many of those things best. So any questions on research object before we kind of do a walk through the user guide and then the unwritten user guide? So yeah.
So is it lightweight compared to CWL? CWL is pretty lightweight, right? It's YAML.
Yeah. It's a JSON file, the manifest. Yeah. But you could have a YAML representation. Yeah. Any other questions on research object? Okay.
What's research about?
Pardon me?
I mean, why do they call it research? I mean, it's a general thing for packaging up a set of
Yep.
outputs.
Yes.
From a process.
Yep. But from a
It doesn't need to be research, does it?
yeah, well, you gotta scope things at some point. I would say in research and academia and the clinical world, there is attention to this provenance and attribution and metadata that would certainly benefit other areas, but that we especially care about or need more. So, that's probably why the R in RO is from research object. So if you're purchasing a system or shopping around or doing some planning, put this on your roadmap. This should be the output. So sometimes we have job runners that will execute our CWL. Some are using whole platforms. This is what the output of the platform should be, right? Don't give somebody just the result. Then they'll lose that connection to all this other information. Give it all together to them. Because there's already a bit of an ecosystem here, and these systems should also be able to consume research objects. If I give you the data, because they'll need all that metadata anyhow, so if I give you the data from my sequencer, I should give it to you in an RO that tells you the sequencer, the serial number of the sequencing machine, the generation of chemicals that were used, maybe the robot or the person who did the sequencing prep. I'm going to need that metadata later anyhow. This is that generalized framework, so it flows all the way down. Yay! Okay, I'm a standards nerd, it's true. So now we're going to look at, what are we going to look at? So since some folks read this, didn't necessarily do it, or they skimmed it, I'm going to talk us through these, and at any time people can stop and ask questions. And for folks staying on the afternoon, this is, be okay that you may not get all the details, because it's more important you have a survey understanding of what's available, so that as you work on your command line tools and workflows in the afternoon hands-on workshop, you know it's available at least, so you can ask or come back and find the more details. And then after we go through this bit, we're going to go a quick walk through some topics that are only documented in the specification that we didn't write up here. And the specification's a bit hard to read, we know. we're sorry. So we're trying to improve, we are improving this document. I've got some get funding right now to spend more of my time on that versus other matters. So I'm, okay, I can't see my screen, so I have to be over here. So we've gone through a lot of this already, sort of real basics. So I might kind of scroll through things, but if you remember when you were reading through this, you had a question about something, this is a great time to ask. You can stop me anytime. But I think we kind of covered the basics about describing and running. This does show an example of using the reference, some implementation, and running a command line tool description at the command line. We had talked about that hashbang line. So when you have, that was the, actually, how's this font size? I probably need to make this a little bigger. There we are. There was that question about the hash exclamation point, user bin, and CWL runner. So if you're doing that trick, then you have just had the path to that file, and then you have just put the job or the functions, the parameters on there. So I think we've covered this. The essential input parameters, give some examples. Here's an example of using a prefix in addition to the position. Was that a hand I just saw? Okay, great, that's okay. You can do a position or a prefix or both. So some you have to have some input binding or else it won't show up. So some programs just need the prefix and they're good. Some also need it to be in a certain order, right? We've seen it all. But just as a hint, you don't always need to provide the position as long as you have some other input binding that will cause it to show up in some way. And then like as a hack, let's say it doesn't need a prefix and you don't care about the position, you can just put, because this is key, this is a key value, right? This is a map. So the key name is input binding. If the value was just an empty dictionary, empty curly brackets, that will show up on the command line following some other rules. So if you don't really care where it shows up and it doesn't need a prefix, that's a shortcut, so you don't even have to specify a position that you may not actually care about. And then I think, here's an example of doing an optional type. You get to add a little question mark. Yeah. That's just a shortcut for, instead of specifying, because you can specify multiple types, and null is an acceptable type. So really the question mark is actually saying, it's this type, or it could be null. It's another way of saying it's optional. So the question mark is a handy shortcut. Sometimes the type declaration gets more complicated and we can't use the shortcuts. But we always try to have this more succinct syntax. So I'm just zooming through this, but stop me anytime you've got some questions from your own reading or from what I'm reviewing here. So that's what this prose is kind of explaining, a lot of the things we already covered and giving some more examples. And then now this part of the user guide is talking about the output binding. So I showed you the easy case when we had standard out, but this is like a folder example of type file. Then we actually have to say, where do you get that file? And we glob. It's just a term from Unix. Let me make this a bit bigger. To give a path. So this is quite a question.
The home example is coming from a PWD.
The which example? Sorry.
You've got the full path is extended, so you've just got path.
Here, yep.
That's expanded.
Yep. So, yep, so let's look at the specification real quick. It's a big document. And what's nice is we have let's see, no, that's a bit too detailed. It's fine here, concepts. Runtime environment. So we actually are very opinionated about some things. And one of them is what the experience is of running that tool. And so here we say that the tool should be run in an empty directory by default, unless you've staged in some other files. And that will provide some additional things, that /temp should be available, but that you could provide a tempdir path as well, that certain environment variables must be set. So we do try to give a lot of opinions about the environment that the tool is going to be run in that you should rely upon, because if that's violated, then it's not a valid implementation of CWL. And this is for portability concerns, and also to prevent surprises. Sometimes we have extra files laying around and they actually get used and we forgot to model them, right? So this is, the reference implementation will actually use a bunch of symlinks and new directories to enforce this, which can sometimes will surprise us because we forgot, oh, we need to include this input as well, or that configuration thing. So yeah, the current working directory is empty. It's presumed that the tool will write into that. If you need to tell the tool which directory to put the output into, you can pass it some of these special variables. So you put this in $ with parentheses, and that will, because some tools you always have to tell it which directory to write in. Okay, that's fine. We can give them that path. So this information is available to the tool. Is that helpful? Okay. How's everybody else doing? All right. So let's go back to this, just sort of walking through these examples here. So this is now explaining that we have this shortcut. So sometimes we might want to, we can specify where the standard out goes to. And then that enables this shortcut if we want it to have a particular name, or we can even leave that bit out and just do type standard out. And because all objects have to have names, typically systems will auto-generate a name for that file, even if it was never written to disk. But here's how you could actually give it a particular name. So file naming is interesting. Different platforms handle files naming differently. For a lot of us who came from the make world or running stuff by our hands, we had to learn how to be very disciplined about file names and creating good patterns so we could keep track of what we're doing. We're kind of tracking provenance in some ways in our file names, putting metadata in. CWL, if you really want to do all that, you can do that, but we actually do not care about file names. We try very hard not to, right? You notice our inputs and outputs aren't about file names. And the CWL descriptions I and others write, we tend to use fixed file names, that are the same no matter how we run the command, but it's in context, we kind of know the meaning of that file. These are sort of different approaches. I feel that using the fixed file names makes it a bit faster and easier to write it, but some people still want these nice human-friendly file names. We support that. You can do it either way. It's fine. But just know that the connections between tools are not all about file names. To get data out, right, when we did that glob, obviously we use file names to communicate with the programs, right? So when we glob, we need to glob on a real file name. When we send the path into the program, we are going to give it a real file name. But that's where it ends. Then we map them to these other identifiers, and that's how those connections are made. There was a question.
So it seems like that you specify the end result output files, and then you can give them like a human readable name, right? But what if it is the case that you're interested in one of the intermediate files that you weren't aware was going to be relevant?
Then you can also make that any output of any step could also become an output of the final workflow. Yep.
But if you've already run the workflow,
then hopefully you're using a platform that makes that available.
will the file still exist?
It's up to the platform. Under documented feature, there is a caching ability for the reference implementation. And if you're running the caching, you could actually amend that step or the workflow to make that now an output of the workflow. And because it cached everything, isn't that nice? You can still get it out. Or you can go look in the cache yourself and pull it out. But that's like not part of the spec that is available. Yep. So if you have an idea that a particular step's output is going to be important and your platform doesn't have a save all my intermediate outputs option, then you need to make that an explicit workflow level output. Do we need to see some pictures of workflows? I had some earlier, but would that kind of help to see? Maybe. Okay, let me pull up one real quick. So I want to show off this website. It's great if you've got a CWL on GitHub someplace. You can upload it and get a visualization. And then note that visual, it's going to be kind of public that you did so. You have to run it locally for now if you want to make these private visualizations. Yeah, so here's one. For some reason, they really wanted to output I guess they indexed the output there. Right? So here's where they made it a workflow level output. But I think it's a reasonable feature to want is to say always save my intermediate files. but that's something you need to work with your provider, your platform with. We should probably start surveying the different platforms to see if they do that. Do we know if Arvados does that yet? Do we know if Arvados always keeps intermediates? Yeah, okay. Yeah.
I think it does.
Okay.
The Galaxy it does.
Galaxy always saves the intermediates. Yeah. Yeah, but they don't quite have their CWL support's ongoing.
Can we not like direct the process directly to the output, the workflow output, right?
Yes, any output, yeah, you can always just tag those as being workflow level outputs.
So it's going to be intermediate plus definable output. So in that way we can actually handle it without the help from.
Exactly. So it would just be a convenience feature to save the intermediate outputs. Otherwise, if you got tons and tons of steps, it's a little tedious to always make those also workflow level outputs if you're editing the text file by hand. All right. All right. So we were just talking about outputs. I think I answered the questions. All right. We're doing the capturing the standard out and those sort of tricks. I really do encourage you to run these. So this is kind of nice to see if you haven't run CWL yet, is seeing what an output object looks like. Here it's represented as a JSON out of kind of convenience. So a file object has some standard fields that should always be present if the file is real, including the size and a checksum. And if you want to learn more about file objects, you can always look in the specification. So here we're in the command line tool description. We split the spec into two pieces. One's for command lines, one's for, so we'll scroll down. And I just want to sort of show what it is kind of like. I look in the spec all the time. So we know that this is what a file object can look like. We have the path with location, we describe the differences. And then we made in some convenience, some virtual properties that will always be available. This is nice when we care a lot about the file name, we need to manipulate it, maybe in how we report the file, or we're combining file name parts in the command line. So we could always pull up the base name, these components of the file's path and name when we communicate to the program, or maybe we're using them to design a new file name. So these are auto-generated by the platform. We will get to say, okay. So back to, oh, there was a hand, thank you.
I've been noticing that there's, for the input and output objects, there's a class file, but then you also have a type file for your command line tools. I'm wondering what the relationship is between those and if this occurs with other types of classes as well.
Yep. So, so CWL's types, let's look at that in the specification. What are the types? So we'll start that. I scroll down and I find my, so here are our core types. Basically inherited, all but the last two are inherited kind of from the JSON world. So these ones with the lowercase one, these you never have to say class whatever, right? Because it can be inferred by the syntax as you specify it. But for these and for file and the directory type, and then any custom types you can make, so you can have enumerations, records, which is sort of a custom type where you have many components. Then you do need to say, yeah, so class means it's an instantiation. Type, so right, because the input objects say it's like a schema for the comp sci people. So it's saying this is what is allowable input. It must be of this type. But the input object over here is saying, yep, I am that type. I am that class file. That's what it's class saying, I am it. And type is saying, you should be this. So we will use type in our command line tool and workflow definitions, but the input objects, if it's file or directory or a complex custom type, then we can declare it using class. Of course, it occurs to us that maybe we don't always need that for simplicity, that maybe that could be inferred. So we might simplify needing to specify the class in some cases. Definitely if it's a custom type, it's helpful. Because right, here's the thinking, if you know that this thing must be of type file, I guess it's when there's ambiguity, right? You could accept many different types and you wouldn't be able to infer, then it's useful to declare automatically.
Are there any examples of people writing custom types or custom classes?
Yes. Let's look at an example. That's a pretty advanced topic, but yeah, let's look at a custom type. I don't think, let's see if we have, This is a slightly confusing example. I'm going to use local blogger hero. What's your URL start with? We're going to use your blog post.
DSCI economics.org. And then just go and scroll down.
There we are. So I think it's the second one had the custom? Okay. So this is an error there is, but hey, let's plug folks who are explaining things well. And here is a custom object. So I actually typically will split this up a bit differently. And I will put the type itself, this part, in an external file. It's a bit of a change in how I normally did this. I did that in the past, but yeah, we can use the schema def requirement or in situ, but this is nicer because it's reusable. We can have a custom record. It's going to have some fields. We'll give the names of the fields and the types that they have. And this becomes, then if you give your new custom type a name and you import this wherever you need it, then you can refer to that as your type. So you can say type file pair, or in your input object class file pair if you need to disambiguate. So this is definitely used. It's great when there are 3 inputs that only make sense when they're provided together. Sometimes we can use that for enforcement. You must provide all 3 or none. But sometimes it's just sort of conceptual. You have to have these 3 together. Let's just make it a single type. Yep, so people are definitely using this. I use this all the time. So you can also have like enumerated lists of like possible values. So maybe,
For example, I think secondary files with the reference sequence, so they have to be with
yeah.
that, so
Well,
they have to come together.
well, let's look at secondary files. That's a little bit different. I think that's in the user guide. So let's go back to the user guide and see how we describe the secondary files. Did we do that?
Maybe it's
Is it not in the?
I think it's in specs.
In the spec, oh great. So we noticed that up here in, there we go. So what we're looking at is the command input parameter, just to give some context here. This is when we're sort of saying what can be there. With a label, as well, we can say we saw that this is where we'd specify the format, that streamable field. So just try to give some context, where we would have the input binding and the type stuff. But there's another field called secondary files. So this is another useful pattern. So the common run right is BAM file. Anytime there's like an index, is very common. Tools that index FASTA sequence files or BWA MEMS indexing stuff. So this is another pattern people will use a lot. Is the primary file, but you need to always have these other ones with it. So it's sort of implicitly a complex type. You should always have these going with it. So just to show another example, I guess so we haven't documented that in the user guide. That's unfortunate. It's pretty common in bioinformatics, I think, for those working in that area. So again, the point of this is just to give you kind of a flavor and a sense of all this. So hopefully you're letting it wash over yourselves, that you can come back to this when you need it, or if you're here this afternoon, you can dive in and get some more assistance.
You might have answered this already, but if you do something like defining a custom type or a requirement or something, how do you import that into your workflow?
Yep, so there is a literal $ include or import. Let me pull up some workflows I'm working on right now. And this is actually what, so this is how I typically do it. So this is EBI's, metagenomics, Teams, new microbiome general purpose workflow that's assembly based. To give you some context. So this is a workflow file. We've seen this before. Here now we get some requirements because we're using some extra bits. So this is like an example, advanced workflow feature. The sub-workflow requirement, everybody's always implemented it, but for 1.0 we made it kind of optional, so we have to kind of flag it when we use that feature. And then for the schema def requirement, to be able to mix from multiple tools, this is the pattern you have to use. So this is the way of pulling in these custom types, We'll then say, well, we're about to do that, and then we'll use the $import to import one type each. So I put my types each in separate files because I need to mix and match at the workflow level. And what's nice about this is often I can import these here, and then maybe I'm using them as default values for a step. So it's, I have an input for a step. I don't want to put it as a workflow input. I want to make that choice. But if it's an input that's used in one of these custom types, I got to make sure I have imported up here. So that's why I have to do that. So does that explain the pattern of? Let's look at actually one of those files to see how I split it up. So we're going to look at the frag gene scan model custom type. So we'll go to that path, tools, model. So it's just a YAML snippet that has that custom type in it. So here it's a bunch of files. I could have done this with a directory, but they actually, each of these files has a different, I wanted to be specific about what these different parts were and give a bit of documentation. So it's of type record, I gave it a name, here are the fields, the names of each field in it, and the types of those. So that's an example of using a custom type.
Is there a subtype?
So you can reuse your types inside other types, yep. So, or you talk about inheriting.
Kind of inheriting, so like this is a subtype of file, so if something that really accepts file will also accept this.
The underlying thing we wrote CWL in to communicate this spec supports that. We did not put that in CWL itself. You know, it could be an area we move into. But there's like complexity management that we're trying to do. So we're open to it, but we haven't quite needed that yet. Because if it's, especially with file, like that should just be a format then, right? Yeah. Then you should say, well, it must be a file, but with this format. Yeah. So in some ways, that was the more common pattern we saw. Okay, so let's step back up our tangents and go back to, I think we're looking at the user guide. But we got moved around, so let's jump back in. I think we were around, I can computer. Parameter references, okay. So we're looking at this tar example again. So parameter references, this is an example of it. I actually personally don't like this pattern, the way we did this. To me, this is a little funny, but it's an understandable example. So here, we wanted to pull out of this archive a single file. So we'll pass in the name of that file. It's going to end up on the command line, and then we'll use that to consume the file. So $ in parentheses, and then inputs means any of the things that could have been up here. And then extract file, so it's this object. What's that type string? So that's very straightforward. I would have just done glob star, because that should have only produced one file. But maybe this is a bit of insurance to make sure you got the file out that you actually wanted. If this was a file object, like you were doing tar, not tar, but something else that produced many files, and you only wanted one of them, then you could access the path, the base name, the name root, all those little components we saw of the file object. So so this does not require JavaScript. It's compatible with JavaScript, but you don't have to have JavaScript turned on or the JavaScript feature enabled. So we'll continue our kind of quick breeze through. So Docker and containerization is always an option if your system supports that. So it's great to add a hint and where you might find that tool installed, a reference to the Docker Hub, a Docker pull command, etc. I can talk more about Docker and containers, but it's not necessarily the main topic of today. And then this is something this is great, especially with a lot of systems where you can tell them where to do their work. So sometimes we need to pass other information to the tool that's fixed. It's not something that the user directly specifies. And so the arguments section handles all of that. Maybe sometimes we do very advanced things here. We didn't want to muck up with the input binding here. So in fact, sometimes all the input binding won't even be in the input section. It'll all be kind of references using that parameter reference I showed you in the argument section. In fact, for probably CWL conceptually 2.0, some major release, we're really going to decouple input binding and output binding from the inputs and output sections. And there's going to be, you'll just do that in arguments, and there'll be like a results section to connect the outputs to what the command did. So it'll clean up the specification a lot and simplify things. Just a preview of what's coming. All right, so we also allow array inputs. Again, you can use the shortcut specification with the square brackets. And then when we bring in arrays, we can do the input binding at different levels. So in this instance, we kind of expanded the typing a bit because we wanted to put the input binding at each element of the array versus putting an input binding for the entire array together. So in this one, we're going to put this dash b equals and then the string before each element of the array. So we had to expand the type, right? We couldn't use the type string bracket because we need to put that input binding right inside the type. It's a bit messy though. You can see like if I was using the include trick to reuse inputs and outputs in other places, I'm mixing my input binding details with this type. And so if that's becoming a problem, that's when you just keep this sort of a pure type specification, and then you'd have that argument section where you map from your types into the command line. So if you ever run into that, you're using some complex types, and you find yourself, well, when I use it over here, I want to embed the input binding this way, but over this tool or this workflow, I need to reuse the same type, but do the input binding, the deep input binding differently. Then keep it separate. Just keep it a pure type reference, and you can do the input bindings in the argument section. A little advanced, so if that went poof, but you run into that situation, hopefully this afternoon, I'll walk you through it, or I can show an example of that. So, and then like we can do inputs, we also do array outputs. So here's the glob syntax maybe make a bit more sense to comp sci Unixy type folks. We can glob on something with a wildcard and get a whole array of file outputs. That's a pretty common one.
And they guaranteed to be safe in their own little directory, so you don't glob in things that you shouldn't be globbing in?
Yeah, so the working directory is always empty by default, so it's whatever the tool put there. Could a user try to use that to glob your Etsy password? Yeah, so the platform still needs to take care of all those sorts of things with permissions and whatnot. So the advanced usage of the custom record feature. I actually had a question on BIOS. So this is good about support. If you need support for CWL, you've got some local experts. Yay! But you also have the rest of the team. So the best way, especially if there's going to be some back and forth, you share some syntax, is to go to biostars.org, write your question. It's like a Q&A site like Stack Overflow, tag it CWL. Even if you don't work in biology, your CWL question is welcome. I answer a lot of those, but other people are starting to help out more too. There is a chat room, if it's like a quickie question on Gitter. It's a mailing list for more discussing how the spec is going to change and grow. Not so good for just how do I questions or is this possible? And then we occasionally meet up in person. So this was a trick using dependent parameters, again, using the record to group these. You had to have both. And the question I had on BioStars was, well, was this a keyword that had to, that's how you do dependent parameters. You name your input that. Nope. So this is probably the confusion here, is we should have named these more creatively to indicate that that was just a made up name for the input. Since actually this is an example of putting the custom type inline, right? I didn't put it up in the schema def, I didn't import it, it's inline. So we actually don't even need the name field here because we're not going to refer to it anywhere else. And then, so they're saying, well, if you're going to provide this thing, item A, you definitely have to provide item B because then you don't have the full record. So it's forcing the user to provide both. Yeah, okay. So again, it's a survey. We're just kind of zipped through this, just so you know it's available. So environment variables can also be useful. They can be referenced, they can be set, and a lot of these requirements can even be overridden in the workflow in the steps definition. So you have maybe a more generic tool, but we'll tweak its usage when we actually execute it, because some tools need the environment variable set. like you do with class path and path sometimes as well, but that's a bit messy. That should already be handled by the platform, in my opinion. I don't know if there's going to be any questions on that. All right, JavaScript. Who wants to talk about JavaScript? No? Interest? Oh, okay, all right. So a little controversial about which language we chose and having it at all. We call this our trapdoor. So there's some cool things you can do in CWL because this allows you to manipulate the object model. But we're very specific about where you can use JavaScript. So if you're reading the actual specification, let's look at that real quick. You'll see this expression. So only fields that have expression listed, could you use a bit of JavaScript to produce that result? And so we learned from other systems that allowed for some really rich templating. It can be a bit dangerous and complicated. And so we're trying to keep things declarative. So all systems have chosen to implement the JavaScript, but some might not. So if you can remove JavaScript from your CWL, it is better. I'll run a little bit. The spin-up time will be a little bit faster, but it's very powerful because it allows you to manipulate things. Like you can do a bit of math, some string splitting. Though this sort of string splitting, if that was a path that we already had, because we saw people doing lots of path manipulation, we added in those attributes to the file object, so hopefully they won't need them as much. And as a reminder, if you're just concatenating strings, you can use parameter references for that, right? The $ parentheses, some value, and the parentheses, other bits, so you can put those all together. It's not necessarily well explained in the specification right now. So do you want me to talk us through this, or any questions about the JavaScript or what it can and can't do? Yeah?
So I'm guessing that you can't, you know how we're talking about making branching workflows where they pass the different outputs and stuff. I'm guessing you can't hold chunks of the program that branch using JavaScript.
Yeah, so that's not you can use JavaScript in the workflows, but not like to consume steps and hide their definition or change that. That's not a feature of CWL. Yep. So if you're curious about like which variables are available, to interact with when you're writing JavaScript, come on over to the specification. We've got more details about that where we describe the expressions and what's available. You can even have a common library of stuff you want to reuse. If you throw an exception, it results in a permanent failure of the process. But the thing I want to show you is this runtime environment. So this runtime parameter is always available inside the expressions. And then another thing is, let me find that just a second. And then here's the namespace as well. So inputs provides all the input object. In certain contexts, self will be meaningful. They'll say that in a spec. And again, the reference to the runtime. So again, we can go into more detail this afternoon or another time, but just to give you a quick overview.
When does it get evaluated?
We say in the spec, so where it's core views, we'll kind of give hints. So there is an over lists when, but it's typically late binding. Pretty darn late binding, yeah.
And if it's like if it's scattering across a workflow, it'll get reevaluated for each scatter job?
Yeah, so if you're scattering and you're using like a record and that value from trick, there's some weird interactions there that make sense from one perspective, but may not do what you want in others. So we do say how that all works together. I mean, if the JavaScript expression is inside the tool definition, then the scattering happens first, and it's at the execution there. Mm-hmm. But if you're because you can use it at the workflow level to produce some values. So the interaction there can be a bit surprising. So for example, if you have a record type, one of the elements is an array, you can't scatter over an element of that array, because the only way to access that is through this value from feature, just in the syntax right now. However, if you pass that whole type to a workflow, and within that workflow, then you have access to that thing, then you could scatter over that array. So sometimes we have to restructure to just deal with how things are right now.
You're trying to make it not be abused too much.
Yeah, so like this is heavily inspired by the power and the danger that Galaxy experienced in all this. It's not a dig on Galaxy. They did this way before anybody else, but their embedded Python in their tool descriptions exposed the entire object model of their system, and users used it. And so we wanted to really avoid that and be very specific about what was available and where it could be used. So not a Galaxy dig. I'm a big fan. We were just trying to learn from their experiences.
So if you've got individual subtasks or steps in your pipeline, can you dictate what the requirements are for those, like whether you need 10 cores of memory?
Yep.
It only applies for that step.
Let's look at
For the whole.
Let's look at resource requirements. So again, in the spec, we kind of go through table of contents, and we will find all these fun requirements. And in resource requirement, we can talk about cores, memory, disk space for the main directory, and then the temp directory. It's pretty basic. There could be some other resource requirements you could use to describe the shape of the computation. You also notice that it accepts sort of the basic type, but also you can compute what's needed. So if you're able to tell based on your inputs, maybe their metadata, how much memory is needed, then you can express it here. Notice there's no wall time, so I don't know if you're all in systems that have like, you need to tell the scheduler what's the maximum execution time. We'll probably add that in later, but you could do it right now, right? You could extend the spec on your own and even support an expression there, because there are some systems out there you could model roughly expected wall time, which would be kind of pretty neat. It means your jobs schedule faster and everybody's happier. So this can be applied. So this expression, this requirement, resource requirement can be within the tool file, maybe to give like, don't give this tool more than 4 cores, it just can't make use of them. So the cores max is useful. But then, so let's open up the workflow specification. So a lot of repeated content, but in the workflow step, I know it's a big, we can specify overriding requirements. So we can say, using this step here. Now again, we still want our workflows to be somewhat generic. So you could do things that are very site-specific here, that's fine, it's not wrong. But you still might want to do some sort of out-of-band configuration if you're saying, well, this step should run on the foobar machine. Now that could be a hint, but maybe that shouldn't go in the workflow you publish. Maybe that should be something in the input document or some out-of-band configuration.
Is there any facility for splitting your workflow into multiple files so that I could have all my site-specific stuff in one place and my generic stuff? Because I could imagine I might want to import this sort of thing, like not lose it. But
Yeah, so the syntax we've been discussing, because not everybody uses an input object. That's just if you're kind of at the command line. Some systems you use the GUI to decide kind of what you're doing. But for the input object one, we've discussed the syntax that allows you to kind of give these per step or sub-step, reach in overrides. And that's the same file you have your local paths anyhow. So it kind of makes sense. But if you're talking about kind of like generic defaults, like we always run it this way, then we should find a way to do that in a system-specific way.
so I guess to me conceptually, the number of cores is more something that goes with the input object than it is something that goes with the workflow step.
Right.
Like it's specific to the data often, not always.
So if you can derive it from the data, then you should use an expression. That's pretty cool, yeah? Yeah, so that's an evolving area. You can get it done for now, and it will get cleaner later as we kind of get more experience. Okay. So we're talking about the resource requirement overrides. By the way, you can create files at runtime. This is great. Could be like an INI file, list of files. A lot of systems would like to, programs would like to get configuration this way. And then a feature we love a lot, and then we get sad because Toil doesn't implement this yet, is the initial workdir requirement. So it allows you to stage files in, even rename them, create a whole subdirectory structure in that working directory, which is normally empty. So some tools need things that have specific names, or it's just more convenient. Or here's a common pattern. You need to index a file. You're running some sort of thing that's going to create a secondary file, and it wants to write it right next to the input file. Well, the way most systems work is that input file is in some other directory that's marked read-only. So you can't write write to it right next to it. So it's best to stage it into the working directory so that that indexing tool or something else that's going to process it, but wants to write a file right next to it, can actually write in that area. So that's a pretty common pattern we see. So any sort of, making a little database or index, you'll need to stage it in.
That doesn't copy the thing you're indexing, does it? Make a copy of it.
I would hope that your implementation would be smart enough to symlink it in, or symbolically or hard link, whatever.
So you need to run CWL, the ability to make symbolic links is critical. Is that a requirement?
Well, we say POSIX, so symbolic links are, yep. And then sometimes you need to be able to modify that file as well. And you can also specify that it should be writable. So not just linked in, but actually copied so we can write it in place. All right, and then this is the user guide talking about workflows. We've kind of covered this already. And then it goes on to demonstrate how nested workflows work. So that's the official friendly documentation. Let's talk about stuff that's in the spec that we haven't really explained well. I've been creating a list, but if people also, in conversations with me or things they found on their own they'd like for me to talk about, I'm happy to add this in our remaining 50 minutes. So the reference implementation I mentioned offhand has the ability to do caching, so just as, but there's some bugs, so buyer beware, and you might have to clear out your cache once in a while. So just run CWL tool, it's the name of the reference implementation, -- help. You can see some of those under document features. You can specify a directory to write some, it'll write all the intermediate files out. As long as they generate command line and the input files all hashed together come out to be the same hash, it will reuse that. That means you can actually tweak the description. So it's not hashing the whole CWL description, it's hashing the result. So you can still make formatting changes, add documentation, rearrange things. As long as it'll produce the same command line, it will reuse the cached files. And it caches the whole output directory, the whole working directory of that tool. So sometimes I forget that I need an additional file. I forgot to add it to my output section. Well, if I have caching turned on, I can add it, and when I rewrite it, it just picks up that extra file and it's available. So it's really useful when I'm developing and trying to iterate quickly on like my laptop or remote system. When we write new scripts, or maybe it's a program that we wrote ourselves, we spend all this time creating these command lines and getting the output back. And wouldn't it be nice to save some time there? And so as a feature, let's see here. Where did we talk about this? There we go. So tools that are aware of CWL can actually produce that output object themselves. It's just a JSON file, key value pairs, needs to match the outputs of your output section. But if you're writing your own script, right, a little bit of Python, Perl, whatever, you can do this to kind of just save yourself some time. And it's such a generic format, people might reuse this in other contexts. Likewise, using the JavaScript feature, we can actually represent the input object, write it to disk as a JSON file or stream it in, and your tool can consume that. So no command line parsing, we don't have to generate one, your little script doesn't have to consume one. And you can see how, well, maybe I've got a function written in my favorite language, Julia, Python, Go, whatever, and I want to use that in a workflow. Well, we could probably develop some little SDKs and libraries just to make it pop in there really easily and not have to worry about this command line business. Yep, so just as an advance, that's what deep integration enables. And because they get access to the whole object structure, they will get all the metadata that might be available and be able to propagate that by hand and decorate the file. So maybe I'm uploading a FASTQ file. We know it's very hard to stick metadata in FASTQ files, but hey, I'm CW aware, so I'll give you these extra fields. So I'm, the KHMR tools, I'll tell you the number of unique KMRs because I counted them. Instead of outputting the things I put on standard out or standard error, unstructured, I'll put that in this JSON file. So I think it's actually potential to be really helpful outside of CWL, right? Is to give more structure to all these little bits of nice information that we just sort of spit out a lot.
Are there any command line parsing modules in any languages that kind of already support loading their as a JSON file as an alternative? Transparently, like they generate it?
Not yet, but it would be very little work. Where it's kind of on our agenda to kind of to work on, to assist with. Yeah, I mean it's almost a one-liner, right?
Probably.
exactly. So almost every language out there has JSON parsing and production built in. And you could even take an existing program and then structure your inputs to match it, right? Like it might be very simple. So you'd probably need an environment variable or a single input, right, to find that JSON file. So you have to parse one little bit, but it's pretty straightforward. So that was deep integration. That was on my list. We talked about finding CWL descriptions. We all don't want to keep describing SAM tools and Trimmatic over and over again. What is the source? How do we find these descriptions? There's a community repository. That's great for now. It's not going to scale. We know that. So that's one place to look. So let's, do I have it open already? Yeah, it's the same way this link came from. Let's go to the main branch. And so you're very welcome to upload your tool and workflow definitions here if you'd like to license them under Apache 2.0. But that's not really going to scale. So if you're searching for them on the internet, because now we have this string is in every CWL 1.0 file ever and beyond, on GitHub and Google, that's actually very effective. So let's see here, if you put that, so name a somewhat common tool, somebody? Anybody? SAM tools, fine. I don't want to find repositories, but I can also go look in code. So it's a quick way to find if somebody else has described something. But, we really envision that these descriptions will be from the tool authors eventually, or at least contribute it, like we might contribute a manual page or other something to an open source project. So if you're doing packaging or you're upstream, they can actually they can write their CWL description to certain paths, and platforms can choose to go find them, either to present them in a user interface, or you can just have that run command in your workflow, run samtools-sort.cwl. Maybe you don't even give it to somebody because it's always going to be there. So I package software for Debian as a hobby because I'm a nerd, for bioinformatics software, and we're starting to include the CWL descriptions as we would contribute a manual page or some other value add. And then we give them to the upstream too. Hopefully they take them. Sometimes they don't, just like with other contributions. So I just want to cover like where to find those. Yeah, we don't want to keep writing these descriptions. We should share them. And I mentioned
XDF data home, can that be a column separated list of directories, or does it have to be
probably. I think it's a single directory. I mean, there's a whole spec about this, about how to find that, right? So I think it's a single directory. It's almost always home directory.local share is the value of that. So you've seen
things like Linux brew packaging systems. They would maybe package their own workflow wrappers, and you'd want to make sure that path was in your discovery path.
Yep. So anyhow, I did all the I don't know what they'll choose to do, but that is the standard for per user configuration files to not muck up everybody's home directory with a bunch of hundreds of dot directories. So it's by default .local share, but it could be something else that they can configure. Yep. And then if things are installed, if you apt-get install soon as it filters down, like things like SAM tools, yeah, you actually will find the SAM tools CWL descriptions at those paths if you're on that source system.
Remember you showed a workflow earlier with SAM tools and some different things. Actually, SAM tools alone doesn't mean anything. It's got different ways to use it.
Mm-hmm.
So in the CWL, how would you do it? Would you have one script for SAM tool view my file, and then one script for whatever the next step is, SAM tool sort, for instance? Or would you have only one script that does all of that?
Yeah, you literally could make a single CWL description for a tool and all of its subcommands and the different way those works. It'd be really difficult, really tedious, and you probably don't need all that. So again, I really recommend taking a tool or even a tool subcommand, just find a single path, find what you need out of it, that's okay. And make those modular, etc., because they will be a lot cleaner. Then you have to do all these crazy tricks to support all the different use cases, and it's just mucky and messy. We really try to be it's like, how do I execute one function or one kind of goal through this one command? And I think it's,
a lot of bias.
yeah, but you know what? there are 50 functions that SAMTools does. Those should be separate descriptions. They'll be a lot cleaner, they're a lot more understandable, they're going to fit together better, they'll be easier to maintain.
So in these repositories, is the assumption that the tool description is only a subset of what's possible? If you have something like SAMTools, it's more complex, or do you expect people to be submitting to them like the complete tool description?
It's community-based, so they should do whatever is useful. So people should pull up what they found to be, I mean, maybe we will develop and we'll do some of the difficult work to add a bit of flexibility. We'll have to figure that out. It's probably going to be kind of per community. I mean, really, that should happen in the community that makes that tool, ultimately. So we'll see. It's going to be an ongoing thing. So there's a separate project out there that thinks CWL is pretty nifty and thinks Docker is pretty nifty. So this is one of what will be many sort of app stores for CWL. If you're kind of doing the Docker container thing, CWL, you can share what you've done on DocStore. So they're nice folks. There will be others. So this is not specific to a certain field, though it did come from the Cancer Genome Collaborative folks. But so this could be a way to kind of share and communicate what you've done. They're big promoters of us. But there will be many. There will never be the science app store for CWL. There'll be institutional repositories and whatnot. They are working for GA4GH to develop APIs for accessing these and remote execution, and hopefully that will lead to federated search too, so at least that the different repositories know about each other. But we're kind of letting them do that on their own speed. But many Common Workflow Language Project community members also work on this. So in the remaining 39 minutes, I'm going to cover a couple other things that are not so well known in the spec.
Can I just ask?
Please.
I'm going to forget. When you talk about CWL, you said basically you're still making changes to it. You're still finding, some parameters might actually not be relevant, it might be redundant, etc. So what does that mean if today I decide to start a workflow in CWL? Like, how is this going to affect my work in a year time?
Yep. So we version the spec, right? We always have that CWL version to say what we're doing. And then we have the reference implementation has always had the ability to silently upgrade to the latest syntax internally. And then we also now have standalone external upgraders. It's likely that platforms will support several generations of syntax, but usually they're very simple changes to go kind of forward to the newer syntax. So we care about that. We want to make it very easy, and it's kind of one of the requirements that we build a map. If it's a change in syntax, we have to build a map from the old to the new. We are following the semantic versioning rules for versioning of the standard, so you can look at the version number and get a sense of how big the changes are. But it is likely platforms will support multiple generations because it's so easy for them to upconvert to the newer one internally. It gets a little weird if you mix and match different versions within a workflow, so just beware. But then you can just do a local conversion up to that version that you need. So 1.01 is coming out with a few little tiny tweaks, mostly clarifications to the implementers. 1.1 is in progress with a couple nice enhancements, but still pretty minor. So nothing too crazy. So a feature to support the radio astronomers, for example. They needed a bit of clarification. So we talked about Docker for specifying how to run a piece of software, but sometimes we're working on other systems, and it's nice to kind of say, what software is this referring to? And even with the Docker requirement, we're not quite saying what the name of the software is or using an identifier. So in all the ones I try to make standard is I have this software requirement section. It's part of the 1.0 spec. It's an optional thing to list what the software packages are. And at first, you can just use the name. So if it's a relatively unique name, there's no confusion, you can just use the name, right? Everybody knows what bowtie is. There's no more than one bowtie. There's bowtie and bowtie 2, but they're separate names. But if you have a sequence aligner named snap, there are 3 of them, by the way. You might want to disambiguate which one you're talking about. So you can actually give one or more identifiers. And the ones I find to be the most robust are from this service called SciCrunch, and put them in the form of this identifiers.org. So I find this to be the most robust thing to do, but I will also have the simple name. So let me just show you an example of this in context. So I'm doing it right now for the EBI. So let's look at the frag gene scan description. And so this is how I actually specify it. And I can also input as a list the version numbers known to work with this particular description. So this is what this actually looks like in practice. So I might still have a Docker requirement as a, even though it's not a true requirement because it's in the hint section, once we finish our Docker containers. But this is nice because maybe I'm using the module load facility or some other way to manage my software, or maybe I'm using Debian packages where you can map from these identifiers to how we're ever managing software in the local system. So I don't know, who's here is going to, if they decide to go to CWL, will be able to do Docker? Yeah? Is Docker available on your systems? So yeah, who wants to do this, but there's no Docker available? Hands, anybody? Or you don't know yet? You should find out. So a lot of the other partners in the project care a lot and use Docker a lot, and I think that's great. So I spend a lot of my time thinking about the non-Docker users, and I have been thinking about use the whole time.
We'd love to use Docker, but we're not keen on giving pseudo access.
Yeah, I mean, there's Singularity, and there's these other approaches as well.
But they don't seem to provide or a shifter, for instance.
Yes.
But they don't, it's not a transparent layer. You got to write a whole different API.
Yeah.
You got to interact with it, so you can't just plug in a Docker call.
Yeah, so Singularity can consume Docker images. There's also a technique using, under many different names, but there's a nice package called udocker, which fakes out a CH root, but without any special permissions, and just sort of extracts the base image and puts it, because the way researchers use Docker is like this, and like the whole function of Docker is huge. We only use this little bit. So there's a lot of innovation going on in that space. We're trying to support whatever people want to do.
Have you thought about supporting Rocket?
Yeah, so once the Open Container Initiative's 1.0 spec, which is like any day now comes out, we will kind of clarify ours to say, this should be whatever. So we haven't decided if it'll be a separate requirement. We'll just rename the Docker requirement to that, because Docker can take OCI containers and images.
Is there Singularity support now?
People are using CWL with Singularity. We don't not support it, but we don't have a directive about it explicitly. You could map between an identifier and like a local thing, or because again, Singularity can consume a Docker image, you could have an implementation that took that and just did the Singularity thing with that. I think from what I hear right now is most people run it inside a Singularity container that's already being pre-configured using like the reference implementation or toil. So it just sort of doesn't know that it's there, but just everything is available.
Has anyone done hints for like directly manipulating a package manager?
Yeah, we had lots of discussions on that, and then there's so many different package managers, we don't want to go through that. So this is kind of, our compromise is that we all have these identifiers, and I kind of, let's see, in the spec, we said, well, you can actually have many identifiers. I think you should always have this most generic one, but you could put in an identifier that was specific to certain systems. Because maybe maybe Conda doesn't have the mapping yet, but we'll put an identifier that indicates the Conda package. Or maybe it's a custom local package. Maybe it's an identifier that means something to our modular load command, because yes, we specified which piece of software, but locally we compiled 5 different versions. So this identifier means something only to our local system. Yeah, we support that. Why shouldn't we get in the way of that? We know how, we've come from these different backgrounds, we've seen this, so I think that covers most anything about this. More work needs to be done on the implementer side, but I think we've covered it, we've modeled it pretty well. So those were some of the advanced features that were off the top of my head. This is a great time for questions, like, is this possible? How would is that possible? How do-Is might take a bit more time. It will be better for the afternoon. But I think I've covered kind of all the big stuff offhand. But I think, yeah, let's do some Q&A. If I could sit for a second, yeah. Questions?
So we use modules, module load, blah, 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 and so how does it interact with that if I'm running a step and that step needs a particular module or set of modules?
Right. So we put it in the data model to support this, but your system that's running CWL, we need to convert from that identifier or the short name. let's go put this example here.
So it's an
Would-
implementation issue.
Exactly. So let's say maybe you want to use toil because that's pretty popular on academic computing and schedulers. You could like have a mapping between this or this and say, oh, this is the default, something else is the default module for frag scan. Or if you have many, you could just invent your own identifier. Please use your domain because module load command names are not normalized across institutions. So just use your domain, module, environment module, whatever, and then the actual name, you could put that there, or you can do out-of-band configuration, which means, and I do this on a cluster at EBI right now, right? I set up the path, they're not even using module load, so I set up the path myself, and I make sure that gets exported all the way through before I call the reference implementation or toil, which is what we're using there at the moment. So yeah, there's some choices. Maybe putting your site-specific one in the tool definition that you share with other people doesn't make so much sense, So maybe it goes in that user object file or some other level. It's not right, especially if it's under hints. It's not wrong to have a bunch of weird identifiers here that may not mean something to somebody else. They're just like, hey, if it's useful, this is the idea of what I'm talking about, right? Okay, people may have asked, why not DOIs? DOIs tend to refer to specific releases or specific papers. These identifiers from SciCrunch, let's look at their website real quick, refer to the idea of that piece of software, any release, just the whole idea. So, and they've actually given identifiers for a lot of software. The project I worked on last already had one, and we never issued it, but we were able to own the listing and add some. So somebody name a somewhat well-known tool? Come on, we gotta wake up. BWA? That's easy, I already know it's in here. Come on. No, okay, fine. Chime, let's do Chime. Cool, so it shows up. So they already have it in here. What's nice, they also search across resources, and you can register your things as well. So if you don't have an identifier for your tool, you can get one from them ahead of time. I think some journals will get these things registered at publication time. But again, so it's not an identifier for the publication or particular release or particular tarball. It's an identifier for this as a concept, as a piece of software. So it's the correct thing to map between different packaging systems.
So sorry, who registers it? Is the author meant to register it?
The author could register it, but some journals will go through and issue identifiers for all resources mentioned, and they'll do these little in-text semi-structured site references. And so that's, I think, how KHMR got registered. We didn't. But when I found it, I was able to own the entry and update some of the metadata that had gotten out of date.
Is Proctor in there?
Let's find out. See, this is what I wanted to hear. I'm pretty sure.
Well, I haven't added it. I didn't even know that. So.
Exactly. Yeah, but that's how when I first found out about this, I was like, oh, I'll see if it's any good. Oh, really? That's fine. Let's see. Hey, you've gotten an identifier. You do.
Maybe it's bioinformatics.
Is this, yeah. Is this up to date? The metadata?
I guess that's the paper, isn't it?
Yeah. They do some.
What sort of stuff would...
So there's some cool stuff on the site. See who gets co-mentioned with you. Yeah, anyhow, so there's other neat things, but the main thing I like about them from this context is they issue these identifiers, and it's right.
How are these associations, these relationships defined?
They're doing full text search of the literature.
Wow, okay.
Of what they know about.
So if there's a paper about a pipeline, they mention a bunch of tools.
Yeah.
They'll pull them all into that relationship.
Yeah.
Okay.
And yes, you should, but the important bit is you can take out this bit right here, and then you can use EBI's identifiers.org resource, which will give you a cool URL for your identifier. So move you from an identifier to a URI or IRI, and it's dead. Well, I think it's because I have HTTPS always turned on or something. But this website normally looks great, so pretend it's looking great. But then you sort of slap that, anyhow.
That's
So
what the internet used to look like.
it's true. It's true. It's probably my local configuration. But so you can take that little RID SCR bit and then prepend it with that to give you a full URI. And so if you do this, it does resolve down to the appropriate side crunch page. So people, and I don't know if they have one already, but they should expose an endpoint so you actually query the metadata. Like, yeah, cool, ecosystem stuff, right? So we're trying to play nicely with other things.
Mark, you said that you wouldn't use this to narrow it down to a particular version or release.
Yep.
Could you pin sort of a version you see that developers specify it has to be run with this particular version of software, otherwise?
Yep. So we had that version list in the software requirement, and is that the? And so you can so it's a list of strings because version comparison is a whole nother mess. You can list versions known to work. Basically, we're saying this description, if you've got this tool in that version, should work. So you might know it might work with others. You could remove them, or I guess you could have an overriding requirement at another level that would, okay, yeah, the general spec listed everything, but the overriding one will lock it down. Maybe it's messy, right? We'll kind of evolve that. It's a conversation with your platform. We make the information available, the platforms then get to decide what to do with it. Because we literally can't force anybody to do anything.
Right, so the platform has to go through it to see if that version is there.
If they choose to, yeah. Yeah. Okay, how are we? Are we full? Are we over full? Yeah? Well, I mean, I think we have a bit more time left, so we can do some questions, we can chat amongst ourselves. Brick early.
Can we go back to that SAM tools question, like the sub-modules?
Yep.
Like, what about naming? Because there's going to be 100 SAMtools.cwls out there, right?
So, exactly, I mean, we got to scale that up. So we, of course, encourage people to submit to the community repository and improve there and refactor and do all that nice community stuff because it's sort of like code. But that we'd also hope that the SAM tools authors would accept it at some point, either participate in the tool wrapping or just accept us giving it to them so it actually gets out to the users. Will people...
If there's a CWL description to bundle with the tool, is that the dream?
There will be many ways people get their CWL definitions. That can be one of them. I hope that happens. I know it won't a lot, right? But we want to make it possible for things to be nice. That's always my goal. I want to make it easy to do the right thing. I don't expect that to always happen. Yeah.
So John was here a while ago talking about Bioconda.
Mm-hmm.
They have a sort of analogous problem in that they want to package up all these tools and they'd like the authors to do the packaging. He was saying they found that one really successful way to get authors to do the packaging is for someone else to do the packaging, but
and then donate it.
Author.
Yep.
And they've kind of got the advantage that there is a central source of packages, or at least there's channels, right? There's a concept of there's a channel, and it's really simple command line interface to access a channel of packages, and then you can install them. So you don't need to know where to go to download a file.
Yep.
You just need to know about the channel. So
yeah, I mean the community repo could be that, right? It could grow into that. It's probably going to get a bit unwieldy at some point. So we can talk like some organizational things. Many people work on the CWL project in various capacities. I am the only full-timer. So I feel like I'm doing like 5 to 7 jobs on a sub-mediocre basis. And so as we grow, I hope to do a couple of those better and then hopefully have more people to do some of the other stuff. But in the meantime, pull requests accepted. But also more importantly, people to review pull requests. Like all open source projects, maintenance, maintainers, and curators. Very welcome. Yeah.
I think he was specifically saying that once someone had wrapped something, so you can have hackathons, which
yep.
A successful strategy was to go to the tool authors repository, to make a repository,
and send it.
A note in the README file saying you can install this using
exactly.
these 2 lines. So I feel like there's a similar opportunity.
Absolutely, that's the plan. I will do some of that, but any of you could go do that with asking permission. Yep. So that's we should maybe write that up and encourage people to do that. We'll start back here, but yeah.
I was wondering if you could talk a little about what tooling is available for CWL, whether it's going to be like editor plugins or anything.
Yep. So things that are coming. So I don't know precisely when they're releasing, but this example is a TypeScript library for working with CWL, and the Rabix team from Seven Bridges is using this to rewrite their commercial platform. So this is a port of what they already had, but open source and more browser-based. Rumor is they're going to release it at BOSC, but it's all on GitHub, so maybe it's usable today. So this obviously would be a great interface for editing the workflows. There will be others. I already showed the visualizer, so for static visualizations of workflows, or a fun way to snoop on what other people are working on and get us, see what's kind of out there. Let me find something especially egregious looking. So it's mostly really polite looking workflows, but occasionally we get, I don't know. So it's kind of neat to kind of see what else is happening out there. But yeah, I mean, these are interactive in a way, in the sense that, let's see if this feature is working today. Nope. There we go. You can use this sort of explore the DAG, like, oh, what's the parent of that node? Or, let's see if I can, what is the, so you can imagine a complex workflow might be not obvious. What are all the downstream steps of a particular, top-level input or thing? So that's available, and maybe that's going to get more awesome. If you're interested in making that more awesome, you should contact that team or chit-chat about it, maybe coordinating some efforts on the mailing list, but that's on GitHub. And then, if I can spell my own project, we do try to list things going on elsewhere. So we don't have plugins for text editors at this time. Contributions welcome.
Are you making the syntax?
Yeah, but you can teach them that .cwl is YAML. That's like a one-line configuration, so that's helpful. But yeah, you're not going to get completion and fancy, like this actually doesn't work, so we'll show it in a different color. Nobody's done that yet, but it's certainly, it's doable. And then there's things to generate your, like an 80% complete description if your script uses argparse or click. We adapted code from the Galaxy project and helped extend that. And then vice versa to generate your argparse for Python command line parsing from the CWL description. So if you're the tool author, you don't want to kind of repeat yourself. That's an idea. But at some point, if you're going to do that level of integration, maybe you should just consume that CWL input object JSON directly. But this is nice if you want to kind of describe a bunch of tools that are written using the standardized command line tool libraries quickly. You don't want to modify how they work. So they won't give you the output section. It won't be idiomatic, but it'll be a start. It'll save you some typing. So that's kind of the tool ecosystem, but it's it's growing all the time. It's the benefit of a standard is that people are developing these, and I've heard of folks like, oh, somebody working on that or this, and you can tell they're going off to make plans, and hopefully they'll release things soon. Yep.
So I've got a command line tool that's already Dockerized. What's this general strategy for making that CWL?
Right, so you want to describe your tools at the command line level, how to make those inputs and outputs.
Yeah.
You'll put in the Docker references, and then you'll wire them all up together to be a workflow. So are they all your tools or third-party tools?
Mine.
Every step is code you wrote.
Oh, no, so it's a single tool, but bigger.
Oh, a single tool, yeah. So you could describe how to generate the command line, or since it's your code, again, you could teach it to consume that JSON file. And you don't have to worry about representing the command line in CWL. It sort of simplifies things. Both are fine. It's your choice. Obviously, if you're just consuming the file, you don't have to it's less work to keep things in synchronous. Yeah.
When I was playing around with it, I didn't really find a good way to debug? And if you have any good strategies for that, and I noticed there's CWL tests. Any good strategies for writing tests?
Yeah. So the reference implementation just got a lot better about doing upfront, deep parsing and verification of the workflow connections. Before, you could have things misconnected and you wouldn't discover till you came to execute that step. And so that's a lot better. It just landed, I don't know if we've cut a release since then. So like within the last couple weeks, so if you haven't upgraded recently, do so. There is a -- debug for the reference implementation that will give you more output than you would ever want to see. I use -- help a lot to check syntax. So CWL tool, my CWL file -- help will force a parsing. What other debugging type things might you? I mean, there's a lot we could have. That's kind of what's out there. I run with the cache on typically to save time.
At some point, I want to just look at a dry run, so just print out the commands it's going to do rather than actually do things.
Yeah, it's tricky because those can vary based on the inputs and input file names. So you can't. There could be a mode. We've thought about that in the past, but because of the dynamicism, that's actually not so straightforward because you don't know what, especially if you're globbing and then something else, you're globbing generally, and so this thing has a file name, and then because people care too much about it, and the later step is globbing specific, I don't know, right? There could be a mismatch there that wouldn't be communicated.
I mean, it's a problem that's been solved before by other things that run workflows.
Yeah,
And sometimes they can't do it completely, but often they can do most of it.
Yeah, so the reference, the Netherlands eScience Center is trying to take the lead on rewriting the reference implementation, both in Python and Java. That'd be great, but don't wait for them, right? You can get started in helping out now. The code's a little rough because we had to iterate very quickly during pre-1.0 period. Like there's very few concrete classes. It's a lot of passing around dictionaries and lists of dictionaries. So that makes it very hard to follow the code in the reference implementation. We know, sorry. Other implementations are a lot cleaner. So I don't know if the Rabix rewrite is in Java, but they weren't really targeting being a general purpose SDK, but maybe there's something there that people can reuse from a Java perspective. There was, yeah.
The CWL viewer.
Yep.
So how does that work? You give it your workflow, the CWL complete workflow type, and it creates the.
Yep. So right now you would give it a URL to something on GitHub because it's running as a public service. If you download it and set it up, which uses Docker, I think you can run it on local things as well. But it's not my code. It's a student at University of Manchester. I mean, there's like a dot output option, but the viewer does a better job of the reference. So we technically have 13 minutes left if people have questions, but if everybody's like, brain melty, we can disband early, but I can still be available.
Yes, I have a question. So if, let's say I want to adopt the CWL approach
Yep.
and new server, so what's the best practice?
Yeah, I mean, this will be a bit of a theme of the afternoon, which is how do we go from what we already have to a CWL description? So I presume you have an existing workflow, yeah? And so just briefly, the pattern really, the invitation is actually step back and think logically about what's happening, to group the components together, to kind of go through our code and find those paths. But it's a real iterative approach. I usually start a bit bottom up. I'll just find the first tool that kind of matters. Sometimes there's things we do in these scripts where we're moving files around, renaming and whatnot that may not actually be totally necessary when we move to CWL. So I try to kind of look past that. Maybe it will be necessary. I'll have to go back and add that in. So I just start finding the pieces. Maybe some of these tools are already described, so I can reuse those descriptions, gluing them together. And so it's an iterative process. I keep building it up, And then ideally, I have a complete run of the existing workflow and then of the new version, and I can do that comparison and see where things fall short. It's now it's the right structure, but now the binary content is different. And I go back and debug and see what I might have missed. So it's this iterative process. If you're in a field though where maybe there's lots of CWL descriptions already for the tools you're using, then that's actually, you could probably move pretty quickly. It's just wiring them together, tracking down what those parameters are, getting some implementation running on your system. Yeah. Okay, I think I'm seeing a lot of full brains and blinking eyes. It's okay, yeah. So let's stop now. I don't know what the lunch situation is, but of course the afternoon sessions could begin at 1:30. So I want to thank you all so much for your time. And yeah, cheers.